This video is to discuss the relationship between tables, graphs, and equations. In the problem we see here, Derek wrote an equation to show the total value of a stack of quarters. The equation is y equals 0.25 times x, where y represents the total value, y is your dependent variable, the total value depends on x, which is how many quarters are in the stack. So we can use that information to make a table of values. X represents number of quarters because they give us that information here. The number of quarters in the stack. And Y represents the value of those quarters. So if we have 0 quarters in the stack, then we have $0. If we have 1 quarter in the stack, then we have y equals 0.25 times 1, which is 0.25. 1 quarter is 25 cents, or $0.25. If we have 2 quarters in the stack, then we would use our equation and multiply 0.25 times 2, and 0.25 times 2 is 0.50. 2 quarters is 0.50, which is 50 cents. 3 quarters would be an additional 25 cents. We could multiply 0.25 times 3, and we get 0.75. 4 quarters is another 25 cents. 4 times 0.25 is 1. We could also determine the amount of money for, let's say, 8 quarters. We could multiply 0.25 times 8. 8 times 5 is 40. 8 times 2 is 16. Plus 4 is 20. 8 times 0 is 0. Plus 2 is 2. 2 decimal places total, so 2 decimal places in my answer. So 8 quarters is $2. We could continue this for any number of quarters. 10 quarters, 0.25 times 10. Bring down my 0. 1 times 5, 1 times 2, 1 times 0. 2 digits in my decimal, so 2 digits in my answer. So my answer for 10 quarters would be $2.50. We could now take this information from our table and create a graph. In our graph, the x-axis goes across, and our x value represented the number of quarters. The y-axis goes up and down, and our y-axis represented the amount of money, the value of those quarters. We could say that we had 4 quarters, 8 quarters, 12 quarters, 16 quarters, because every 4 quarters represents another dollar. So you would want to pay attention to how they put numbers on the x and y axis, because there's a lot of different ways we could represent this situation depending on how we put numbers on our x and y axis. We could have went up by 1, 2, 3, 4. We could have changed it to go up by bigger numbers, but the equation shows that this number represents how much for every 1 quarter. So 1/4 is 25 cents. 2/4 is 50 cents. 3/4 is 75 cents. 4/4 is $1. So here we see 4 on the x-axis is across from 1 on the y-axis, showing me that 4/4 is $1. We also determined that 8/4 is $2. 12/4 would be $3. 16/4 would be $4. So we can see how this line represents the relationship between how many quarters and how much money. The number in the equation tells us how much for 1. So 0.25 can be written as a fraction, and that's 0.25 over 1. So that's the amount of money, that's the value for 1/4. And that's how we determine the equation, is we come up with the amount per 1. This is a unit rate per 1. Another example, the cost of 4 ice cream cones from the snack bar was $11.20. If each ice cream cone counts the same amount, then create an equation, table, and graph to match this information. Well, first thing is, again, this equation, you have to come up with the unit rate. So our cost, we have cost, and we have number of cones, number of ice cream cones. Our cost depends on how many cones you purchase. So our cost depends on something. So our cost is dependent. So that is our Y value. The number of cones we purchase is our X value. So we have cost $11.20 per 4 cones. To come up with the equation, we need cost per 1 cone. So since I have to divide by 4 to get my denominator to be 1, I'm going to divide my numerator by 4. 4 times 2 is 8. Subtract 8 from 11, and I get 3. Bring my decimal up. Bring down the next digit. 4 times 8 is 32. Subtract 32. I get 0. I can bring down the next 0 to see that 4 goes into 0 times. So my cost, when I divide the top and the bottom by 4, my cost per ice cream cone is $2.80. So this helps me write my equation by dividing the total cost by the number of ice cream cones. I can get my equation where the cost is $2.80 times the number of cones. Now, very similar to the previous example, I would be able to use my equation, substitute numbers for how many cones I'm buying. I already know 1 cone is $2.80. 4 cones is $11.20. Another example, looking at graphs. When you're looking at a graph and you're trying to determine how you would match that to an equation, remember, when we have an equation, y equals a number times x, this number represents the unit rate. And a unit rate is how much per 1. So if we look at our graph here, the number of strawberries, 1, has 3 calories. So that would be 3 calories per strawberry equals the total number of calories. Whereas the number 1 here has less than 1. If we look closely, we see that 3 strawberries have 1 calorie. So we can say 1 calorie for 3 strawberries is equal to 0.3 for 1, because I divided 3 by 3 and 1 divided by 3. 1 divided by 3 is 0.3 repeating. So this 1 right here is paired with 0.3 repeating. So this would be y equals 0.3 repeating, or 1/3 x. So you'll notice on this graph, we don't start with 1, we start with 5. And 5 strawberries have 1 calorie. So number of calories per strawberry, it's 1 calorie for 5 strawberries. 1 divided by 5. 1 divided by 5 is 0. Add a decimal and a 0. 5 goes into 10 2 times, is 0.2 for 1 strawberry. So this equation would be y equals 0.2x. Because again, you are looking for this number to be the amount per 1. The y value, calories per 1 strawberry.